Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is theoretical probability. Probability can be divided into two different categories. First one is theoretical probability and second one is experimental probability. Let us see what are these. Theoretical probability is a probability that is determined on the basis of reasoning. Experimental probability is a probability that is determined on the basis of the results of an experiment which is repeated many times. Do you understand the difference between these two? Okay. In this video, we are going to focus on theoretical probability. Let us just have a small recap on the basic definitions of the probability. First one is experiment. Experiment refers to an uncertain process. Second one is outcome. An outcome of an experiment is a single result of that experiment. For example, if a coin is tossed and it lands with either a head or a tail facing upwards. Am I right? So an example outcome of tossing a coin is that it lands with a head facing up or it lands with a tail facing up. Next basic definition you should know is sample space. Sample space of an experiment is the set of all possible outcomes of that experiment. The sample space is denoted by the symbol S and the size of the sample size is denoted with n of S. Even though we are usually interested in the outcome of an experiment, we need to know what the other outcomes could have been. Okay. A probability is a real number between 0 and 1 that describes how likely it is that an event will occur. That is called theoretical probability. We can describe probabilities in three ways. As a real number between 0 and 1, you can either give it as a decimal number, or it can be written as a percentage, or it can be written as a fraction. Hope you are clear with these probabilities. Okay. So in case if you are getting a probability question, you can either give your answer as a decimal, or a percentage, or a fraction. All are acceptable. We have to note something about the probabilities. A probability of 0, it means that an event will never occur, impossible event. If the probability is equal to 1, a probability of 1 means that an event will always occur, certain event. A probability of 0.5, 0.5, this means that an event will occur half the time or one time out of every 2. 1 over 2 is nothing but 0.5. Am I right? When all of the possible outcomes of an experiment have an equal chance of occurring, we can compute the exact theoretical probability of an event. The probability of an event is the ratio between the number of outcomes in that event set and the number of possible outcomes in the sample space. Hope you're clear with this formula? Okay. Now let us see few examples on theoretical probability. And let us also apply this formula. Here is an example. A learner wants to understand the term event. So, learner rolls 2 dice hoping to get a total of 8. Which of the following is the most appropriate example of the term event? Let me list out. So, please look at the examples given. Event set is 4, 4 and event set. Okay. We can recall the definition of the term event here. An event is a specific set of outcomes of an experiment that you are interested in. Am I right? So among these three, the most appropriate example of the term event is event set 2635445362. Am I right? Okay. So this is a general basic example. Now let me take few examples and explain you how to apply the formula and get the solution. Here is an example. A learner finds a 6-sided die and then rolls the die once on a table. What is the probability that the die lands on either 1 or 2? We can give our answer in some simplified fraction for this problem. First, let us find the number of outcomes in the event set. So, if you are rolling a die, the total number of outcomes is 6. Am I right? Because it is 6-sided die. And they are asking the probability that the die lands on either 1 or 2. So they are just talking about the 2 faces of the die. Am I right? So the number of outcomes in the event set is 2. As I told you, there are 6 possible outcomes. The number of possible outcomes in the sample space n of S is 6. Finally, we can find the probability. I'm just going to write the formula here and plug in the values that we have got so far. Here is the formula for a theoretical probability problem. N of E is 2, N of S is 6. So 1 over 3. In case if you are going to give your answer in a fraction form, please make sure that you have simplified the fraction. Okay. Hope you're clear with this example. So this problem gives us the clue, gives the information directly. Now let us see one example where you have to collect all the information, gather them and find the probability. Here is an example. Even numbers from 2 to 100 are written on cards. What is the probability of selecting a multiple of 5 if a card is drawn at a random? So even numbers from 2 to 100. So how many numbers would be there? There would be totally 50 numbers. So if you imagine a set of numbers starting from 1 to 100, you can circle around the even numbers starting from 2, 2, 4, 6, 8. So totally there would be 50 cards. They are all even. And all numbers that are also multiples of 5 or multiples of 10. Am I right? So the even numbers would be 10, 20 to 100. So there are totally 10 of them. So now finding the probability would be easy. Total number of even, the number of even that you prefer is 10. And total number of all possible outcomes is there are 50 cards. So 10 out of 50. I'm talking about this. This is total number is 10. All even numbers starting from 2 to 100. So totally 50. Now plug in these two values in the formula and then simplify the answer. Hope you're clear with this example. So just analyze the question and take down the given information carefully. And for these types of problems, you have to be clear with this counting. Under the topic probability, for sure you'll be getting some problems in tossing a coin, rolling a die, taking some color balls from a bag and picking a card from a deck. So I'm going to show you few more examples on taking some color balls from a bag and picking a card from a deck. Here is an example. A bag contains 6 red balls, 3 blue balls, 2 green balls and 1 white ball. A ball is picked at a random. Okay, determine the probability that it is red, blue or white, not green or red. Please look at this question, the way they have asked you. This one is a direct one. So you can easily find what is N of E, N of S and plug that in the formula. Please look at this one, this or that. And the third case is not an event. And fourth case is not an event or something else. So let us see how to answer these types of problem. First let us do the part A, finding the probability of red. Okay, probability of red. Totally there are 6 red balls. Am I right? And also let us find the total number of ball in the bag. 6 plus 3 plus 2 plus 1. So there are totally 12. 9, 10, 11, 12. So 12 balls in the bag. There are 6 red balls and total number of balls is 12. Now let's find the probability of getting a red. So probability is 1 over 2. Second case is blue or white. So blue or white. Total number of possible events. I mean the successful event. If you're picking a ball, it should be either blue or a white. So total number of successful outcome is 3 plus 1. 4. And total number of balls in the bag is 12. The same thing. So this is how you have to find N of E and N of S. If the case is this or that, you have to just add all the possible outcomes and add all the possible successful outcomes. Now just plug in these values in the formula and simplify it. That's it for this part. And third part is not green. Since we are just talking about theoretical probability, I am not going to give the formula for probability of not an event. We are just going to focus on the method how to solve a problem under theoretical probability. So not green. It means if you pick the ball, it should not be a green ball. It can either be red, blue or white. So total number of successful outcome would be 6 plus 3 plus 1. Am I right? So here the probability would be 10 over 12. Same way for the fourth case, not green or red. It should be some other ball which is not green or red. So the total outcome would be, you should just ignore these two colors, red and green colors. So if you are excluding these two colors, what are the leftover? 3 blue and 1 white ball. So total number of successful outcome would be getting a ball from blue or a white one. So 3 plus 1, 4. and total number of outcomes, possible outcomes, the total number of all the balls in the bag is 12. So 4 over 12. Same concept. Hope you're clear with this problem? Okay. I'll take one more example from the card problem. A playing card is selected randomly from a pack of 52. So there are totally 52 cards in a deck. Determine the probability that it is a picture card. A number less than 4. The 2 of hearts. Okay, we have 3 cases here. First, let us start with a picture card. So how many picture cards are there? There are 3 picture cards in a suit and there are 4 suits. Am I right? So totally 12 picture cards are there in a deck. So n of E is 12 and n of S, the total number of cards, is 52. So probability of getting a picture card is 12 over 52. If we reduce this fraction, we'll be getting 3 over 13. Hope you're clear with this part? Okay, now let's concentrate on part B. A number less than 4. Okay, for this one, for each suit of 13 cards, there are 13 cards in each suit and there are 3 cards lesser than 4. Am I right? So these are the cards which are lesser than 4. So A, 2 and 3. So totally there are 12. Am I right? And overall total is 52. Same, you'll be getting the same answer. 12 over 52, which is 3 over 13. Hope you're clear with this. So if ever you're getting a problem from card, just imagine this deck. Then it will be easy for you to identify. Okay. Now the third part is the 2 of hearts. So in the suit of hearts, you'll be just having only one card which shows the number 2. So 1 out of total 52. So that is the probability of the 2 of the hearts. I have covered all the types of problems under theoretical probability. You can keep this as base for solving the other problems. Hope you're clear with the concept theoretical probability now. In case if you have any query regarding this, kindly let me know.